Thank you very, very much for this opportunity. I love this. My partner Bruno and I started TRI, the Thinking Research Instruments, almost 3 years ago. Before that, we were supporting the life sciences from our point of view, the physics and computer scientists' point of view, for a lot more time. And when we did start TRI, we did it because there was just too much work. Let me explain. So, first of all, there's too much work on the plate of domain experts, of biotechnologists, of biomedical researchers. These are really smart people. These are very highly skilled people. And one thing that happens when you have a skill that you're better at than anybody else is you get to do whatever that is a lot. Like, for example, you get to, if you're an expert in cell culture, then you get to look at cells a lot and tell whether those are good cells, bad cells, whether they're reacting to a treatment or not. And you spend a lot of time with that. And that compounds and creates a lot of work that keeps you from your actual work, which is probably why you entered the field, coming up with hypotheses, coming up with experiments, curing cancer, those kinds of things. And that's a pity. Now, in this day and age, of course, the solution to this is to apply AI to the problem. Like, this is a really repetitive task. It requires special skills. You teach a machine to do it. And that takes a lot of work off the shoulders of the domain experts. Problem is, it puts a lot of work on the shoulders of people like me. People who know how to teach a computer, teach a machine to do the domain expert's job. And that's perfectly fine. I'm fine with doing a lot of work, except there aren't too many people like me, at least not enough people like me. And also, again, oftentimes it's very repetitive work. You can apply the same algorithm to very different questions, like, is this a neurite? Is this a nucleus in an image of a cell? It's the same algorithms, and it's repetitive work, and that makes that means it's a lot more work than needs to be done. And of course, we were looking for a way to change this, and then to take more work off our shoulders, and therefore give the domain experts more, make them more productive. That's why we started TRI Thinking Research Instruments, to build and design thinking research instruments which encapsulate entire workflows. So you get from your question to your answers in a lot less time, without having to rely on people like me. We have 2 products so far. One is the Vader, and it's the embodiment of this idea. It's it's an integrated system comprising a microscope and a computer, and the software that acquires the images from the microscope, tracks all the primary data, the image data, but also the metadata, lets researchers define their own morphological research without having to know anything about machine learning, and then apply these readouts to their new samples. That's the first product we have. Second product is the Saber. It's a newer product than that. And what that does is it images iPSCs or iPSC-derived cells in bioreactors, in 3D cultures. Previously, you had to do a lot of work to get samples out of bioreactors, of course disturbing your culture, but also spending a lot of work, only doing this during office hours, and spending a lot of time that could be spent better in that. And our system looks at these cells 24 hours a day, takes a picture every few seconds, and analyzes each picture using artificial intelligence again to tell you how many aggregates are in your bioreactor, how big they are, whether they're like really fuzzy or nice and round. And again, that takes a lot of work off of the shoulders of those who would otherwise have to do complicated things to know what's happening in their bioreactors, and therefore takes time off takes work off their shoulders to do the actual important stuff. Of course, 5 seconds, 4 seconds are not a lot of time to talk anymore about our system, of course, and our solutions, but we do have a lot of application notes on our website. Go there, find out what else we can do. Thank you very much.